Good afternoon, everybody, and welcome to the 2021 Mathematics launch. I am Andre Lamprecht, a proud employee of the Western Cape Education Department, and I am managing the mathematics in the Western Cape grade 4 to grade 9 in just under 1,700 schools. But I'm enjoying every moment of it. Colleagues, today is really an historic occasion. Historic in the sense that we're going virtual. It's quite new to all of us. And then very special today is our colleagues from the Eastern Cape joining us. Welcome to you guys. Colleagues, it's really a privilege to have you with us, and now that we can work alongside each other, and hopefully we can get into a little competition mode eventually. To take us to the official welcome this afternoon, I'm going to hand over to Ms. Jewel Harris, the General Manager of Growsmart Properties.
Hello, I'm Jewel Harris and I'm the founder of Growsmart Educational Program. Our program started in 2010 when we started off with just a literacy competition, and I cannot believe so many years have passed where we have completely evolved to being an educational program. When we started way back in 2010, we were just a literacy competition aiming at grades 4, 5 and 6 learners, and all we did was spell this word, define it, and use it in a sentence. Well, lo and behold, here we are so many years later, and we do so much more. Our program has evolved to cover story writing and poetry. In fact, we have several authors under the age of 13 who are published, and those published books have been redistributed to our Growsmart schools. We also include mathematics, science, debating, and we have recently introduced entrepreneurship. Our debating and entrepreneurship is for our grade 6 learners. So not only do we run these programs, but the best thing is that actually all the work that we do is curriculum based. That means there's no additional work for any teacher in the classroom because all the work that we cover is already covered in your classroom. But what we do is ensure that everyone has fun with our digital program that we are now launching this year, and all our material that we use. Absolutely everything is done to encourage the child to have fun while they are learning. So not only have we expanded our program over the years, but also we have taken our program to various provinces. So we partner with the Western Cape Education Department, the Eastern Cape Department of Education, and also the Limpopo Education Department. So such a pleasure to actually partner with the education departments and bring about change in education. Our program has also started a bursary section. So our learners who make it through to our various competitions, and from semi-final round, we open up the doors and introduce them to our bursary partners. And through that, they are able to apply for high school bursaries. But we didn't stop there. Since then, we've actually managed to place several students in university and watch them grow through the various degrees that they are doing, such as medicine, politics, and various sciences. So an absolute pleasure to know that we have taken a child from primary school through high school and then onto university. So Growsmart is really bringing about change, and what an absolute pleasure for us to be able to do that through Growsmart Properties. Watch the space and watch us evolve and partner and grow throughout the years and bring about change. We are Growsmart Educational Program. Thank you.
You finished?
Hello.
Thank you, Jewel, for those encouraging messages and the warm words of welcome. Colleagues, the next up is just the mathematics competition format for 2021. Quickly want to share this with you guys again. Yes, I know everybody's got the dates and very excited to start going. But just to emphasize the following, we've decided to have a couple of practice rounds, actually 2 of them, and that will take place on the 19th of April and the 4th of May. Then we will beef it up into level 1, which will take place on the 27th of May. Level 2 will take place on the 30th of July. The semi-final, and the excitement will be growing by then. The semi-final will take place on the 26th of August, with the final for 2021 taking place on the 9th of September. So that's just a couple of dates for you guys to note, very important dates around the mathematics to remember that we will roll out in this year. Colleagues, now let's get down to business, really into the mathematics, the Growsmart Mathematics. The objectives around this Growsmart Mathematics program is just the following. We would really like to strengthen the number sense development of our learners. Now, if you ask me the question, what on earth is number sense and where is that in the CAPS document, I can tell you that it's about having pictures of numbers, having the ability to see a number, breaking it up and interact with the number. The next objective is consolidating number bonds and the number facts. Now, colleagues, this is very explicit in the CAPS document and indicated under the mental maths topic. And yeah, the CAPS do really guide us into consolidating number bonds and number facts. But not only just for the sake of singing along and road counting. If you do engage with the number bonds and number facts, especially in the intermediate phase, we rely on you to use concrete apparatus to build pictures of these bonds and facts of the numbers. Critical to use concrete apparatus. Then we would also like to consolidate the basic operations, and in the intermediate phase, we're working in a slightly higher number range as in the foundation phase. And yeah, basic operations, whenever we test on international testing and even in the ANA testing, you will remember those, the basic operations remain a problem. So that's why we've decided to include that into the Growsmart project to really provide opportunity to consolidate the basics. Then developing problem-solving skills. Colleagues, we are quite concerned about the aspect that we drill and only focus on procedural fluencies and focus on algorithms in the mathematics class. But what about applying these number bonds, these number facts, applying your number sense and your skills that you develop through basic operations? So if all that comes together, the ability to solve problems in a real world context, whether you call it routine or non-routine, is critical to provide our learners with competency-based skills. Now, the format of the competition is actually very simple. It consists out of mental maths, and I think we're all quite familiar with the mental maths methodology. Then it's about the basic operations in higher number ranges, but critical here, colleagues, is the order of operations. You also know it as BOTMAS. So order of operation, I know it only kicks in grade 6, but nothing stops you to give them a taste a bit earlier. So the focus in grade 6 of this competition, learners in that level, because they are familiar with the order of operations, they should be able to deal with this. And then also problem solving, the routine and non-routine, just to distinguish between routine and non-routine. Routine is your so-called your word problems. Those problems that are quite familiar in your textbooks, in the DBE workbooks, So just putting the basic operation into a certain context and the ability to write a calculation plan from there. But then we come to the non-routine problem solving. And this is really about applying higher order thinking skills. And if you get to develop this skill with a learner, your learners will suddenly be able to take part in the AMISA Olympiads, in the South African Math Foundation competitions, and all over the place. And if you look at our learners taking part in that, the numbers are quite low. So that's a clear indication that we should spend more time in developing our learners' ability to do non-routine problem solving. To come back to the mental maths, colleagues, as I mentioned, it's indicated, oh, sorry for that one. It's indicated in the CAPS document, and the calculation strategies are quite explicit there. And it's really about recognizing and using the commutative, associative, distributive properties of whole numbers. Recognize and use are the verbs here that guides us. It's not about knowing the definitions of all these complicated properties, colleagues. They don't need to know the definitions, but they must be able to recognize it and use and apply the knowledge of those properties. The next one is 0 in terms of its additive property. I think you are all familiar with that one. 1 in terms of its multiplicative property. And then, as I mentioned earlier, we're sense of numbers, your ability to break up and breaking down and build up numbers in your head. Colleagues, and not just breaking up, but remember how you've broken them up. Rounding off and compensating. Rounding off is a relative aspect or a concept that we're familiar of, but the compensating is not that straightforward. So our learners need to be, that aspect needs to be taught to them. Then in the CAPS document, it's also very clear, using addition and subtraction as inverse operations. And how do we teach it, colleagues? It's about checking the correctness of your answers. So the same with multiplication and division. So you see the mental maths, the skills that we're developing in Growsmart, the Growsmart competition, is about consolidating what we do in class on an everyday basis. We must not look at it as an add-on. It's consolidating a valuable opportunity for us to consolidate what we do in class, those high priority skills that we need to develop. The next slide is just a slide to demonstrate to you one of the properties that I just referred to, the identity property, sorry for the jump there, of 0 and 1. The additive property of 0 provides a rule, colleagues. I'm sure everybody can do that one. The multiplicative property of 0, so any number multiplied by 0 will give you 0. The multiplicative property of 1, so any number multiplied by 1 will give you the number itself. If we dig into the calculation strategies and we start refining them. Colleagues, the first one here, as indicated in the CAPS document, is about counting forwards and backwards. Now, counting forwards and backwards, it's not really about singing along in the class with the instruction just for the sake, because the CAPS said so. So it's not really about start to count in twos from 10 to 50 and back, and they start singing and they sing, one follows the other. There's quite a reason or a purpose why we do that. We need to apply that skill of us to count forwards and backwards. And then also, colleagues, it's not about just numbers, recalling numbers. If we start in the intermediate phase, I refer to the using concrete apparatus, the 100 chart. It's critical to use that because the sequencing is important to them, and if they use that enough, they will be able to get a picture. If they count forward, they will be able to zoom into any number on that 100 chart, and they will be able to count forwards and backwards in the steps that's needed. The example here is 73 plus 8. So that's a very easy one. So you will start with 73 and you will count in ones further. But colleagues, this requires the ability to back and have a picture of the number. So once you start counting in ones forward, you have to remember, you need to rely on number sense, and you have to remember how many times you have added the 1. And therefore, some in the lower grades, learners will rely counting on their fingers, and as they progress into through the intermediate phase, they should be able to count without using manipulatives. The next number is a bit in a higher number range, and now the CAPS document indicates you must be able to count in 2s and 5s and 10s, and here I've used an example of counting in 10s. So 535 plus 10 plus 10, and remember number sense will provide them the ability to remember how many 10s they are and the 5 added at the end to get to the 570. So the calculation strategy here is about counting forwards and backwards. Later on, I will show you these calculation strategies that's included in the teacher resource packs that we've provided our teachers with, and I think therefore everybody should be familiar with it. And we recommend these calculation strategies indicated in the CAPS document, that every week we will indicate which strategy you must teach, because it does not come automatically with our learners. The next calculation strategy that I just want to spend some time on is about rearranging. The numbers change places. So if you get an example like 9 plus 27, it's complicated to start from a very small number and then add a higher number. You just swap it around. And why? Because the learners will be able to apply their knowledge of the commutative property of addition and multiplication. So you see, in this instance, they will be able just to use commutative and swap their numbers around, combine it with another strategy if they would like to, the counting forwards. They can say 27 plus 1 plus 1 plus 1 until they come forward to the desired number. So that's just sort of combining two of these strategies. The next one, colleagues, it's I think everyone is very comfortable with this one. It's about multiplying with, oops, sorry for that one, multiplying with 10, 100 and 1000. I'm not going to linger on that one. I think we can go on to the next one. There's a number of other calculation strategies that I would like you just to take note of. That's about renaming, bridging by using other numbers than 10. In the intermediate phase, sometimes our learners really struggle with bridging numbers other, for example, time, that when they need to bridge numbers, they would want to work with tens and hundreds, and it's not really applicable in that context. Multiplication tables, straightforward one, that one, colleagues. The question always is about learning your multiplication by heart and not knowing really what it means, or by studying the patterns and especially using the skill of doubling and halving to do the development of those multiplication tables. Then also multiples by 10, I think we've just referred to that one. And when we work in powers of 10, that's actually a grade 7 skill that we want to do. Doubling and halving, very helpful, and that's a skills that comes right from the foundation phase. So doubling and halving not only of even numbers, also uneven numbers. Then the next one, multiplication and division of single digit numbers, colleagues, and breaking down to these numbers to primitive ways to solve. And that's a combination of breaking down numbers and counting forwards and backwards. And then obviously our learners that struggles with the fractions and decimals, percentages, actually all equivalent representations indicating the relationship between those concepts. So I think we just need, because the caps indicates you teach fractions, then you stop with the fractions, then you will do decimals, and then you will do percentages. So sometimes the equivalency between those concepts gets lost. So, but for us as teachers, it's vital to really point out the attention to our learners to this one. Okay, I hope everybody's got pen and paper ready by now, a pen and a paper. I'm going to give you an idea. The purpose behind is to give you an idea of the pace that's required and applying these calculation strategies in getting to the mental maths answer. So this is a typical demonstration that we can do in the classroom, colleagues. If you do that in your classroom, there's a certain mental math strategy also indicated. So once a week you should consolidate, and the recommendation is here towards a Friday. You've taught the calculation strategies, and on a Friday you need to determine what the level of your learners are. Are they with you or not? Do you need to reteach a certain calculation strategy? Because you should not continue these calculation strategies build on each other. And once you get to the end of the intermediate phase, that must be really part of their skills without going in, digging too deeply. Okay, everybody ready? I'm going to show you the 10 questions and I'll talk you through the pace, the required pace, and then we'll get to the memorandum as well. I will also read that to you, just for the sake of embarrassment. It's after all, it's Thursday afternoon. Hey, so the first one there is 29 plus 11, 6 plus 10 plus 6. Note the pace. 125 minus 5. 250 plus 250. 119 minus 100. 110 plus 110. 299 plus 2 minus 1. Number 8, 300 times 3. Number 9, 100 plus 0. And number 10, 4,500 times 0. If I just can quickly take you back through this. Colleagues, the first example here, you will see filling up to the nearest 10. Okay, so filling up to the nearest 10 will require 29 plus 1, breaking up 11, so 29 plus 1 plus 10. The next one is 6 plus 10 plus 6. Now, colleagues, we tend to only add 2 numbers. Why not exposing our learners to adding more than 2, more than 3 numbers as well? Just a word of advice, don't use too large numbers if you go there. 125 minus 5, you will see working backwards to the nearest 10. So I can also apply the skill here of counting backwards. I think everybody knows the next one. It's really about applying doubling. Number 5 is almost 10 and taking it back then to 100. Number 6 is doubling again. And then number 7 is having the 3 numbers calculating there. So rearranging, you're welcome to rearrange there or use order of operations here. Say for first you will do plus 2 minus 1 will give you plus 1. So it's actually just 299 plus 1. So applying the skills you will pick up. 300 times 3, that's multiplication with powers of 10. Identity element of 0 indicated in number 9. And if you multiply with 0, we'll get 0 at number 10. Let's quickly say how much you got. Answers 40, 22, 120, 500, 19, 220, 300, 900, 100, 0. Okay, and you can give yourself a pat on the shoulder if you got the 10 out of 10 there. Righto, colleagues, the second round of the competition is really about basic operations in higher number ranges. And here it's about BODMAS. So let's take a look at the BODMAS acronym. It explains the order of operations to solve an expression. I think that's straightforward. And then, according to the BODMAS rule, if an expression contains brackets, we have to first solve and simplify those brackets. Then by powers and roots, but in the intermediate phase, we should not go there. It's only in grade 7 where we will touch on the powers and the roots. Then division, multiplication, addition and subtraction from left to right. But now I want to recommend you to do the following. Colleagues, our learners are struggling with this. And yes, when they do when they use the calculator or the calculator on the cell phone, it automatically uses the BODMAS. So the recommendation for this one is that you take this slide and you take a Koki and you write it on a newsprint. Nice large newsprint. You can use color to make it more attractive. And once you've written this down, you put it up against the wall in the front of your class so that learners can see it every single day. So if they look up, they must be able to see it. And if you do a calculation, especially early in the grade 6 year, colleagues, it's nothing wrong if you do this with your grade 7 as well. They will see, aha, that's the order. So they will be able to form a picture of this one. If I take you to a couple of examples of BODMAS, so colleagues, here it's about the first one there is 3,200 plus 800 minus brackets and multiplication. I'm not going to ask you at this stage to calculate it, so let's talk through them. So if you look at this expression here, how on earth, what is the order of operations that I should apply here? It says brackets, yes. So the first one here is the brackets. You will add the brackets. If I've done that, oh my, what's next? Then it's multiplication. So once I've solved what's in the brackets, I need to multiply with 1. Okay, so now I will have 3,200 plus 800 minus 2,500. And now you see it's a plus and a minus sign. So BODMAS will tell you, you solve it from the left to the right to get the answer of 1,500. The next example, which operation signs do we have here? We've got a multiplication and a division. And what does BODMAS tell us? We solve it from left to right. Number 3, let's look at the operational size there. We can see a plus, a minus, a plus, and a minus. Yep, you're absolutely spot on there, colleagues, if you said we solve it from the left to the right. The fourth example here, a bit more complicated. Just have a look at the numbers that I've used here, working towards the nearest hundreds again, or the nearest thousands as well. You say, what do I have to do first? Brackets. But now there's 2 pairs of brackets. So solve the first set of brackets, solve the second set of brackets, and then there's the division sign waiting on us. Okay, so hopefully you got that answer there. Okay, colleagues, the next part of the Growsmart competition deals with problem solving. Again, I want to reiterate that we should distinguish between routine and non-routine problem solving. Now, the question again, routine problem solving, we tend to call it word sums. So that's a common example that you will find in your textbooks. All the textbooks that's on the DBE list of approval, lots of those routine problem solving. And there you will be able, once you read it, and we go into the next slide, we will have an example like that. Once you've read through the example or the problem, you will be able to see, this is a calculation plan that needs to apply here. You will also call that a number sentence. The non-routine problem solving, and that's, as I mentioned earlier, requires higher order thinking skills. So colleagues, a non-routine problem solving, we can describe that as when you have to solve a problem and you don't know how to do it. And a typical response from your learners in the classroom will be, if you pose the problem like that to them and say, teacher, I don't understand it. Is this an addition or a subtraction or a multiplication sum? They immediately want to go to the routine because that's the only thing that they are familiar with. Now, regarding the non-routine problem solving, colleagues, we strongly recommend that we use the pedagogy of Polya. Polya, also regarded as the father of problem solving. And Polya identified 4 steps in the process to solve non-routine problems. First thing is this aspect is that you need to understand the problem. Then you need to make a plan. Remember what we said, a non-routine problem, when you have to solve a problem and you don't know how to do it. Carrying out that plan that you've just made, and then looking back on the plan. And very often you'll say, I didn't manage, it's not working, I have to do something else. So these phases should not be interpreted as a linear step-by-step recipe for problem solving. It's a cyclic dynamic process as illustrated here. So just to explain that to you, they will engage with a problem and they will say, no, I can't, if I use this strategy, I will not be able to get the answer. Then they have to go back, it's the cyclic dynamic process referring here. They need to go back and redevise a plan, carry that out and looking back. So colleagues, unfortunately, our learners are not conditioned into this process. They need to be condition. They need to become familiar with it, because we live in an era of quick, everything is quick fixes, quick answers. So our learners need to, you need to teach them how to endure and to keep on struggling until you get, making plans until you get to the answer. Together with these phases, Paulo formulated several problem-solving strategies or heuristics to help us in problem solving. And we will take a look at them in a moment. The example that I promised you is about problem 2 here indicated. So Peter works as a volunteer for 16 hours a week. If he works for 35 days, how many hours did he work? Now, read the problem again. Now read sentence 1. Now you need to take out your most important information in this sentence. And I think the most important here is about 16 hours a week. So number 4 indicates that get rid of the unnecessary information, get rid of the noise, because Peter works as a volunteer. It just complicates, especially the reading if your learner struggles with reading. So the critical, most important information in sentence 1 is 16 hours a week. Then we take the next one, the next sentence. If he works for 35 days, how many hours did he work? What is the most important information there? 35 days, how many hours? So the next step will be now to plan a strategy. You work through the first 6 steps here and now say, okay, I've got an idea. And now I think, oh, I know how to write a calculation plan for this one. It will be a straightforward multiplication eventually. Right. If we get to Paul's heuristics or problem-solving strategies, the heuristics is a very difficult word. Don't even go there. You can just stay with the problem-solving strategies. And we only want to emphasize these 5 for the sake of this competition. The first one here is making a sketch or draw a diagram. Yes, it's a lot of words. I will take you through examples just now. Introduce some notation or symbolism. Guessing and checking. Making a table and at the same time looking for patterns, and use special cases and be systematic. Right. So our first problem here, colleagues, and again, in the teacher resource pack that we are providing our schools with, for the first 6 months, remember I said this is not an add-on, it's part of the curriculum. For the first 6 months, in grade 4 to grade 9, we will give you a problem per week. Sometimes, if it's a 2-week lesson cycle, we will provide you with more than one example. And then we also indicate the suggested, listen to the word, the suggested strategy. Not the heuristic, the strategy. Let's keep it plain and simple. So we will say, to solve this problem, we recommend that you make a sketch or you draw a diagram. So, typical example here, Arnold drove 10 kilometers east, then 5 north, then 3 east, then 11 south, then 13 west. So if you pose this problem to your learners tomorrow, they will say, teacher, oh, I don't understand this one. Do I have to multiply or add? What on earth? Because if I add north with east, I'm not going to get anywhere. So this is where the steps of polio is kicking in. So the question here is, how far is he now from his starting place? So, colleagues, the possible solution around this one is just, it's not really about you guys solving it. I know everybody can solve this one, but it's about going through the steps of polio. So don't get it right the first time. They should endure, try again and again, making another plan, making another plan. So this one, the example here is draw it physically. Writing it or drawing helps to get your ideas in order. The other day I had a workshop in George, and excellent example, that group of teachers used markers that they use in physical education to map it out on the floor of the school hall. That's also an exciting one, just to bring the concrete, the feeling of the concrete apparatus to them again. So the first one here is about making a sketch or a drawing. Our next heuristic, colleagues, is about introducing some notation or symbolism. If you get this one, this is a typical South African math challenge, or we call it a MISA challenge. How many triangles of all sizes are there in this figure? You are going to get so mixed up if you want to stare at the picture and just try to solve it in that way. It will be merely impossible. You might be able to guess it, but it's not about guessing. It's about going through the heuristic or the strategy. And here, remember we said, introduce some notation. Some notation. And look at the notation. There's a lot of logic in this notation. We start with, we've numbered our triangles, and BE, we're working the base BE, then we work with base EC, then we work with base BC. Next up, we work with base CF, we work with base AF, and we work with base of the larger triangle ABC, base AC. So you'll see there's specific ordered notation that will eventually bring us up. So you cannot get mixed up here by just looking at the picture. The next one is about analyzing a simpler case. The example that I chose here is about how many rectangles of all sizes are in this figure. There are 20 small rectangles. Colleagues, to count this, okay, there's one large one, and then there's a little one, and there's another one. Oh, that's also another one there. You need to generalize to solve this one and using a simpler case. And in this example, you see, we're not going to try to solve the 20 rectangles. We use a simpler case, A, B, C, D, E, F, and then combine it with a notation, order notation that will provide us with logic in reasoning it out. You can even use 4. If you don't want to do 6, you can say, okay, I'm only going to use A, B, C, D, 4 rectangles indicated in that graph. It will provide you the same result. The next strategy is about guess and check. And colleagues, sometimes you just say, oh, I've got no idea. So guess and check it. And a typical example here is the bicycle and tricycle example. How many bicycles are there? And an example on how to use this and apply this guessing strategy is about, for 19 wheels, we can have that. And for 3 tricycles, 10 bicycles. So you might end up with a lot of calculations, but eventually you will end up with the correct guess when you add up all the wheels. Our last one that I want to show you today is making a table. And yes, when you do content area 2, geometric and numeric patterns of the CAPS document. I think you're all familiar with it, but if you put that in a certain context where it's a bit more complicated, you first need to draw it. And then from the drawing, you can go over to a table and look for a pattern. And I can promise you, you will always be able to find a pattern. So colleagues, don't go too complicated when you start preparing your learners with examples like these. Go with easier examples from, say, from grade 4 and 5, where if you prepare your learners for the competition, just to get them into identifying patterns and extending certain patterns. Right, that is just an example that I wanted to show you. If you put the numbers into a table, you will see, added 4 every time, your pattern immediately jumps out in front of you. Okay, now the big question, how to prepare your learners for this competition? Colleagues, and yes, it's, as I mentioned, it's not an add-on, it's not rocket science, it's part of your daily teaching practice. So regular daily mental maths as per strategy. Those guys in the Western Cape, I'm very happy to, Eastern Cape, I'm very happy to share our strategy, because we've got a very explicit strategy in talking about a number that will aid you in developing number facts and number bonds. Every day, using concrete apparatus early in the intermediate phase and reducing eventually. It's not about taking a mental maths book from a publisher, throw it into them or make a copy and say, today we're going to do mental maths and 20 examples. Lots and lots of the same will bring you nowhere. The calculation strategies, I quickly want to go to our resource pack and just share this with you. This is what we're sharing with our teachers that we use here. Colleagues, you will see here that I refer to the calculation strategies that needs to be taught. In week 2, we want you to develop those 2 calculation strategies and we provide you with examples of them. Okay, so you will see it's every week is indicated in your the planning that we provide you with. Then also I refer to the problem solving, the non-routine problem solving. It's all there, colleagues. As I mentioned, for the first 6 months, I indicate the strategy that we recommend you to use. There, you've got your example. Oh, it's too quick. This is your example, the Pac-Man. It's similar to the example that we just had. And colleagues, if you're not familiar or comfortable with it, we provide you with an example video. You can either use your phone's QR scanner, or you can go to the link and watch the video to enable you to see, oh, this is the methodology, how I should guide my learners and how I can teach the strategy of drawing a picture. Okay, just in a quick, take you back to another link that I want to share with you. Come on. Yeah, there we go. So, colleagues, that's the mental maths scheme that I've referred to, that we recommend you guys using on a daily basis over 8 weeks, 32 weeks. Even within a COVID context, it will work. If you don't know how to use it at all, here's some guidelines on how you can use this strategy to develop your learners' mental maths ability. Just to quickly refer there, read the number to each other, it's a critical skill. Breaking down the numbers, the place value, one more, one less, lies between half, double, they are all there. It's about consolidating number skills, mental math skills on a daily basis. Yeah, colleagues, I think that's from my side. It's about what I wanted to share with you. Colleagues, just a final word. Don't leave this until the day or 2 days before the competition and then start to developing it. It's the Growsmart is not only about 1 or 2 learners that we want to support and want to consolidate the basics of mathematics. So this is something you can see it's built into your teaching plan, what's supposed to happen on a daily or a weekly basis. You should attempt to stick with it and do it on a regular basis, and not only, as I mentioned, to 1 or 2 learners. All your learners should have the opportunity to do this. It's not about only those 3. We're there for all our learners in the system. Yeah, and that's about all from my side. I don't know if there's any questions. Atla?
No, okay.
Okay. So, colleagues, as I mentioned, I'm very happy to share in the Western Cape. If there's still some schools that does not have it, you're welcome to make contact with your subject advisor. And our colleagues in the Eastern Cape, I'm very happy to share, and we will just share it via the protocol line. Yeah, it's because it's about our learners. From my side, thank you so much for attending the session, and good luck with your preparations. Thank you, colleagues. Can I leave?